Right now we're on part 2, and then we're now proving that if a line is drawn from the center of the circle to the midpoint of the chord, let's look at the statement. It says to the midpoint of a chord, in the middle of a chord. It means that this part will be equal to this part, because that line drawn from the center of the circle is drawn to the midpoint of the chord. And then it said that it is said to be perpendicular to the chord. Now then we need to prove that it's perpendicular to the chord. Remember, we said the word if, it is a condition, right? And then we have given a practical example with what happens on a daily life, that if it rains today, and then we'll stay at home. If it doesn't rain today, then we'll go to the park. So it is a condition, it implies. So now, okay, the first thing we're going to do, we're going to construction. Then by constructing, we're going to draw or join. Let's join line AC and AB, right? So we're going to join the two lines that we're talking about. Okay, there we go. Let's join AC based on our construction. Okay, then we have joined our side. So now we have two triangles that we're going to work on. We have triangle. In triangle, we're going to work on triangle ACD and triangle ADB. So now, based on the two triangles, we can say that we now can look at AB also and AC. Those are radius. So those are radii. We have line AB and line AC. They are equal. So a line drawn from the center of the circle to the circumference across all the circle, all the lines are equal from the center to the circumference in a circle. So now we can say that AC, it is equal to AB, radius, right? And when they're two, they're radii. So we're going to say radii. And then again, we have another CD. We have CD and also BD. Remember, in the statement, they said to the midpoint of the chord, to the middle of the point. That means that CD and DB, they're going to be equal, because a line drawn from the center of the circle to the midpoint, to the middle of the chord, then means it's going to divide that chord into two equal parts. Okay, then we're going to have CD to be equal to DB, and then that is given, right? And then again we have this line, which it is common in both triangles, triangle ACD and triangle ACD and triangle ABD. So now we can say AD, it is equal to AD from the other triangle. Then we can say those are common, and you can say AD is common. Okay, so then we have two triangles. We have triangle ADC ACD, which is congruent to triangle ABD. Why we saying they are congruent? because we have shown that side AC, it is equal to AB, and CD is equal to DB. So that is side. So the sides are equal in length. So you have proven that those sides are equal. Then now, in that case, now we can say A angle D, it is equal to A angle DB, it is equal to A angle DC, right? Those two are equal because you have proven that the two triangles are congruent. However, that line that is drawn from the center of the circle perpendicular to the chord, to the midpoint of the chord, then it is perpendicular to, it is drawn to the midpoint of the chord, and the midpoint and the chord, remember, that is a line, that is a straight line, and it's drawn to the midpoint of a straight line, and basically it forms a 90-degree. Then that is an angle on a straight line, then that will be equal to 90 degree. Okay, I'm going to repeat that. A line that is drawn to the midpoint of the chord. The chord is just line CD, and then it bisects it. So for it to bisect it, that is perpendicular, and it will form 90 degree. Then in that case, now you have proven that the line, if a line is drawn from the center of the circle to the midpoint of the chord, then it is perpendicular. It forms a 90 degree.